Okay, so where we left off the other day is I got the rear suspension out of the car. And the reason I did that is because I need to figure out, investigate why the car doesn't like to start when the engine has any temperature in it at all. After it's been running a few minutes, the starter will barely crank it over. It's not a starter issue. I have replaced the starter a couple of times. I'm confident this starter test is good, and it cranks like crazy when it's cold. The way the exhaust system is routed, the headers come up off of the exhaust ports. They don't go down. So the starter does not get heat. So here you get a little bit of a view. That's a heat shield that covers the header. So the headers come off the exhaust port, they go up and rearward, and they go out onto the package tray, like you see there. Right? Now, way down there, actually, let me scoot under the car real quick. As you can see, so that's the clearance area in the bell housing for the starter nose. Now, my starter's nose is not exactly aligned with that because of packaging of the starter between the oil pan and the engine block. I don't know how much you can see there. But anyway, yeah. So the top of the starter, yeah, this kind of blows. It's not the greatest view. Anyway, what am I looking at? What do I see here? Oh, this is the shift cable. There's a shift cable there. So there's the end of the solenoid, B plus cable. So anyway, yeah, not the greatest view. Whatever. And that's going to be way too close. But the important thing is, you can see that there's no exhaust anywhere near the starter at all. It is all wrapped in sheet metal, ducted with a bilge fan that is mounted right there. Picks up air under the car, blows it through the header heat shields, pushes all that heat out the back. So the starter, after the engine has run a bit, you can put your hand on the oil pan and go, damn, that's hot. And then you can put your hand on the starter and go, huh, it's about ambient. The only time you feel its starter have any real heat in it at all is after I slow crank it for several seconds, and it barely just and then the starter gets hot from that because you're putting such a great load on it. So it seems to me like there is some mechanical interference, some misalignment, something that's contributing to that, and that's what I'm trying to figure out. So my next step in this process, yes, I said process, that's Canadian for process, or maybe it's German, I think they both say process. Either way, what I'm going to do is pull the Transaxle out and see if the car exhibits the same issues when I don't have the load of the input shaft, any possible eccentricity there. Then I can also take some measurements of the starter gear relationship to the ring gear on the flywheel, and I can also measure the plunge depth, all that sort of stuff. So I'm just going to go ahead and get at it now. Probably go to time lapse and shoot some of this stuff. I just like walking around looking at the car because it's come a long way. Obviously still got a long way to go, but we'll get there. Alright, so it's several minutes later, and I've been sitting here thinking about this and wondering what sort of stuff I can do before I actually pull the Transaxle out, if there's anything I can learn with it in its current situation. So what I've done is I've taken an orange Sharpie marker, and I've drawn a line where the bell housing meets the adapter plate. And what I'm going to do, oh, and then up here with a different color Sharpie, I'll put a little hash mark on the side of the bell housing and an alignment mark on the adapter plate itself. And what I'm going to do is I'm going to try and look at two things. I'm going to jack up, I'm going to support the weight of the Transaxle here, and then I'm going to loosen the 6 bolts that hold the Transaxle to the adapter plate. And I'm not talking about taking the bolts out, I'm just going to loosen them up, quarter turn, half turn, something like that, just enough so that the clamp load is released. And then I'm going to jack up under the Transaxle, and I'm going to see if it actually moves vertically. That's what these lines down here are going to help me with. And then I'm going to load it a little differently and see if it rotates any, and that's what the alignment marks here are going to help me with. The reason for that is, again, because I have some suspicion that it may be a eccentric loading misalignment of the input shaft to the Transaxle that's causing the pilot bearing maybe to get hot, or the input shaft to get hot, and it's binding there somehow. I'm not even sure if that's a reasonable suspicion, or if the load that it would put on the cranking system would be enough to make it slow crank the way it does. Either way, never hurts to do a little experimentation, so I'm going to see if I can measure any differences there, any movements there. And some of you might be thinking, well, if you have the alignment dowels in place that don't allow such movement to happen, how the hell could that movement be happening? And the answer is, I don't have those alignment dowels in place. Not between the bell housing and the adapter plate. I do have them between the adapter plate and the engine block, but I don't know why I didn't machine the adapter plate to accept those dowels. And on the Audi Transaxle, it's not a dowel per se, it is an alignment sleeve that it would go in two of the mounting bolt holes, and then the bolt would pass through it. But anyway, just talking out loud and trying to figure things out. Of course, talking out loud, if it wasn't out loud, it wouldn't be talking. It would just be thinking. What I meant to say was thinking out loud. Sometimes I get caught up in my narrations and I forget how to use English. Yeah. Okay, so now that I've got the bell housing attachment bolts to the adapter plate loosened up by half a turn each, I'm now going to move the camera a little closer to my alignment marks, and I'm going to try two things. The first thing is I'm simply going to try jacking up under the transaxle to see if it causes any, or allows any vertical movement. And then I'll also get a pry bar in there somewhere and see if there's any clocking that can happen. So let's give that a go, see what's up. So first step will be to try and jack up a little bit right here with this floor jack and see if we get any relative motion here. I think the bolt pattern is drilled so close to the actual bell housing bolts, basically used transfer punches to align the holes to the adapter plate, and everything should have been centered on the pilot at that time, so I don't think it'll move much, but it might. I'll give it a try. Nope, it's actually lifting. You can see a little gap here. It's actually lifting the entire power drain off of this jack, and the reason I put this jack here was to support the weight of the engine and also the weight of the transaxle before we did any of those things. So we can see that it's not actually letting the transaxle move, at least not vertically, or positive vertical, I guess. Maybe it could drop down some. Now that I've got the bolts loose, I could take and lower this jack and see if the transaxle comes down any. So I'll try to carefully do that and not smash my head or anything else. Let's see what we get. Come on, baby, give me some love. Okay, so the weight now is completely off of the jack that was supporting the transaxle. And the lines are still visible here. If I raise and lower, now I'll be able to clock a little. Yeah, it's got very little clocking available. And you can see, if I hope that's a good angle. Let's see if I can see what's on the screen here. Alright, try not to look at my face, because it'll scare you. But yeah, if I push up here, you can see that there's obviously some clearance between the bell housing and the adapter plate, so it's loose, right? And that's how it should be, because I loosened all the bolts. But that should allow me to rotate if there's any rotation available. I don't really see how rotating is going to help any, though, or is going to change the situation any, because if it can't shift vertically, then rotation certainly not. Rotation's going to be about the center, right? I got a pilot in the crankshaft, like this, and then I got a pilot on the input shaft of the transaxle that's going to be concentric to that. My concern was that I was loading it eccentrically one way or the other, or maybe just on a bad angle, which I wouldn't really see how the angle would happen since I got a machine flat surface on the bell housing and a flat plate and a machine flat surface on the back of the block. So there shouldn't be any angular misalignment, like in terms of the axes of the engine crank and the trans input shaft being at not collinear, right? What I was thinking was more maybe eccentric, this way, that way, whatever. That could cause binding, but I don't know, maybe I'm just wasting my time, because how much of that binding could really, how much drag could that bind cause, and could it make the engine slow crank? I don't know. I don't think so. But anyway, let me see if I can refund this a little bit and make it twist, just because I'm a nerd. I don't like checking things like that. Very, very small amount of angular displacement. I really didn't expect there to be any, because, like I said, the pattern was made in the plate by using transfer punches, aligning everything on the pilot before the big hole was cut for flywheel clearance, and then using transfer punches to align the locations of the bolt holes, which is also the reason I didn't think that the alignment dowels would really be necessary. I thought they'd be redundant, because the pattern is defined by the bolts, by the transfer punching of the bolt pattern of this actual machine casting, right? So the pilots are there more for an alignment and a production environment, when there can be some variation from piece to piece, but when you're only working with one piece and you make something that exactly fits that piece, then there's no reason to allow to need the pilot to the pins, the dowels. Cool, I'm rambling, and I didn't really learn anything from this. So I think the next step is going to be to pull the transaxle out, and that way I can see what the real relationship is between the nose of the starter and the flywheel ring gear, and I can put a wrench on the balancer bolt, and I can rotate the engine through different positions, and either with feeler gauges. Feeler gauge is probably the easiest way to do it because of the teeth on the flywheel ring gear. Can't really put a dial indicator on that and rotate it and watch the sweep of the dial, because each one of those teeth is going to make it chunky and clunky, and the probe will fall in between the teeth, and then it fucking will rotate and knock my shit all fucked up. And when I struggle for words, I drop swears in, because they seem to work pretty well for me. I've been doing that since I was about 7 years old, I think. Maybe younger, I don't know. Okay, slightly different idea. No, it's not perfectly applicable, because the engine has not been running, so everything is at ambient temperature. But, see, I've got that wrench hanging there on that the lowest bolt on the output flange, and that wrench is just hanging there, and it can move freely. And the reason I'm doing that is because I've shifted the transaxle into 6th gear, which would be the largest amount of axle output shaft rotation per degree of input shaft rotation. And I've got my 5/8 socket on my balancer bolt in the center of the crank, and with just a normal length 1/2 inch ratchet, I'm going to turn the engine. I'm not taking spark plugs out or anything like that, so I'll be cranking against whatever compression is there at that speed and such. But basically, I just want to see or feel how much torque it takes, how much force in the end of that wrench it takes to rotate the whole assembly. Because like I was saying previously, I don't even know if thinking that it's transaxle drag causing it to crank slow once things warm up, I don't even know if that's a real concern. So I would think with transaxle in 6th gear, that would be the most resistance, because it would be the highest number of output shaft revs per input shaft rev. and I should be able to judge from that kind of how much resistance the transaxle is causing. Yes, I did slur my speech a little there. I meant to say transaxle. Anyway, yeah, so let's give that a go and see what happens. Oh yeah, it's an open diff, but I have the output flange on the other side blocked, so it can't rotate. So the one over here will rotate instead because the diff will be turning. So I can't get my fingers around the handle of the wrench really. So basically I'm getting these 3 fingers on the ratchet handle like this. And that's all the grip I can put on it. And you can see that it's open. So I think I may be barking up the wrong tree here. And I'm also doing it with my left hand, which is my offhand. I've rotated it more than 90 degrees so far. Yeah, 90 degrees of crank. So I just keep doing it because I can. And ideally, go around 2 crankshaft revolutions, which takes the engine through its full cam and timing and all that sort of stuff. Everything goes around twice then. But yeah, this is, I'm barking up the wrong tree here. That is not difficult to rotate. So, yeah, whatever. Maybe it's just going to turn out that the Audi starter for a 2-liter engine, 2-liter 4-cylinder, just doesn't have enough ass to turn a fucking 10.5 to 1 compression 5.7-liter V8. Yeah, I've already been around 1 full turn on the crank. I feel like this is going to bear any sort of fruit at all. This is just, as my dad would say, fly screwing at this point. Fly screwing is defined as a lot of effort, which gives very little value in return. Imagine how hard it would be to screw a fly if you were anything other than a fly. So yeah, I mean, I can get both hands on the handle, but there's a lot of things in the way that are stopping me from really being able to reef on it. And that's already been around 1.5 rotations. And the only reason it feels harder in some places is just because I have bad angle on the handle of the wrench and not really applying my force tangentially. I'm doing my best though. So, yeah, again, this is fly screwing for sure, but sometimes at least you can learn something from it. I can eliminate this as, potentially eliminate this as a cause. Fuck, alright, go get this shit out as I go. Yeah, I don't really see how this would be part of the problem. If I just do a couple clicks on the ratchet at a time, that's much easier for me. Yeah, that's already been around 2 full years, so I'm fucking bailing my idea now. But I still feel like I learned something. I can at least say that I learned that that's not the issue. Okay, so here we are in whatever part of this process we're in. Part 1, part 2, fuck, I don't know. Just dragonfly buzzing around, that's kind of cool. Anyway, what I'm thinking is, the garage floor has a bit of a slope downhill that way. And you can see that the gap between the rocker panel and the garage floor is not even from front to rear. As a result, back end's jacked up, floor slopes away. I'm going to put the trans mount back in so that I can take the 2 jacks out from under the powertrain. Obviously, the one's not supporting any weight right now. But the reason I have to put the trans mount back in and take those jacks out is because I'm going to raise the front of the car so that the body is parallel to the floor. And what that will allow then is, or at least will get me closer to, just being able to shove the transaxle straight forward without having to worry about raising and lowering it to match the angle of the powertrain relative to the floor. So if I can raise the front of the car so that the rocker is parallel to the floor, then the way I've built all the mounts and everything, basically the crankshaft centerline I think is parallel to the rocker panel as well. And then that means that would be parallel to the floor, and the, what do we call it, the dang thing should just slide parallel to the floor. I should just be able to roll it in instead of having to worry about the height of it as well as the angle of it relative to the floor. So that's what we're going to take a shot at, and see what happens. Okay, so important note here. In the earlier shot, I did not have jack stands on the front. I still had the weight of the car supported by the hydraulic jacks. That's a no-no. I know that. I'm glad that I get a chance to tell you. So now you all know that, if you didn't already. Don't leave the weight of the car supported by the jack. Use your jack stands. Now, I will confess, I was just doing that out of being lazy. And I only put the jack stands back under the car because I needed the hydraulic jack to do something else. So yeah, there you have it. Safety third, kids. Okay, so I got all 6 bell housing bolts out. Clutch hydraulic line is disconnected. The shift cables are disconnected from the linkage. And I need a ratchet strap because I want to strap the transmission down to the trans jack. But of course, projects interrupt projects. And last week when I went to pick up my motorcycle, I took all my load straps with ratchet straps with me, and I gotta go get one out of the van. And the van's probably not gonna let me unlock the doors because there's something draining the battery in about 3 days, every 3 days, 3 days without action. So I gotta go deal with that. Week. So in real time, that was about 6 minutes. She runs like a top, but there's something, I believe it is an issue, a pretty known issue in the Odyssey world with the limit switches on the sliding doors because they don't power open anymore, and they do something funny when the cable pulls them in the latch. So anyway, I'm gonna worry about it. I'm just gonna let it run for 10-15 minutes to charge up the battery. I'm gonna get back to working on the Corvair. It's my SS, and I love this car. It's so sweet. And yes, it's a manual, because manuals are life. Okay, so now for this part, you have to imagine that the battery didn't die on me. And we have footage of me actually pulling the transaxle out. Because there it is. And you can trust me. And I tell you that I pulled it out and rolled it right over there to where it's sitting. Anyway, yeah. So now I gotta put the exhaust system back on. Because I'm not gonna start the engine without the exhaust system in place. Tempting though it may be. And yeah, first thing I'm gonna do is just rotate the engine by hand and take measurements of clearance in various places from the flywheel to the starter nose. Although I can't really change since the starter's bolted to the adapter plate, and the adapter plate is bolted to the engine, so the starter can't move. And the flywheel is bolted to the crankshaft, so it can't go anywhere either. So I don't know, right now I guess I'm just sort of sliding under the car. I'm trying to show you one thing I have seen so far, which I knew about, and I don't really know quite how bad it is, like, as far as being an indicator of what's going wrong. But you can see the starter ring gear is in there, that's the steel bit, right? And then you can look at the aluminium, British for aluminum, behind the starter ring gear, and you can see that the teeth of the starter have been mashing into it. It's about 1/8 of an inch deep, say 3 millimeters, axially, and it's probably a problem. It's probably contributing to my problem anyway. Anyway, I'm gonna take the flywheel off, and I'm going to rig up some sort of method by which I can clearance that aluminum out of there so that it's no longer a problem. You feel me? That's what the kids say these days, I think. Anyway, yeah. So that'll be my next move. And I'm really excited about it, as you might guess.